Review question 3, differential equation. The first part, sketch the slope field. You will not have to do that on this year's AP exam. They are not going to have you guys do any graphing at all. It might be more like the practice test you just took where they give you a slope field and you have to answer questions based on the slope field they give you. But you will not have to sketch your own slope field. So we're going to go to part B, find the second derivative in terms of x and y. If dy dx is 2xy squared, we have to do a product rule, but it's also implicit differentiation. So the first 2x times the derivative of the second, derivative of y squared is 2y dy dx, plus the derivative of the first, derivative of 2x is 2, times the second, which is y squared. Now that dy dx that we have in there has to get replaced by 2xy squared. So we really have 4xy times 2xy squared plus 2y squared, which gives us 8x squared y cubed plus 2y squared. You could factor it, take out a 2y squared, and you'd have 4x squared y plus 1. But there is our second derivative. So that's part B. Part C, find the equation of the tangent line at the point 1, 2, and then use the equation of the tangent line to approximate the value of f of 1.1, and is this approximation greater than or less than the actual value, and give a reason. So, write an equation of a tangent line. We need a point, which they gave us at 1, 2, and we need the slope. Well, we just sub 1, 2 into our 2xy squared. 2 times 1 times 2 squared is 8. So here's our tangent line, y minus 2 equals 8 times x minus 1. We use that to approximate f of 1.1, so we sub 1.1 in for x, gives us 8 times 0.1, which is 0.8. Y minus 2 equals 0.8, so y equals 2.8, which is approximately equal to f of 1.1. Please include that because it is an approximation. We want to know if this is an over or under approximation, so we have to look at the second derivative, which we got in part B at the point 1, 2. So we sub in our values and we see that our second derivative is positive. Since the second derivative is positive, the tangent line is an underestimate because the graph is concave up. If our second derivative were negative, the graph would be concave down and the tangent line would be above or an overestimate. But when we're concave up, the tangent line is an underestimate because the tangent line goes under the curve. And now the last part, solving the differential equation. So we have our dy dx is 2xy squared. First, separate your variables. Cross multiply if you have to. So we get dy over y squared equals 2x dx. Dy over y squared, let's be careful of that. We're not going to do a u sub. It's not ln of y squared. Dy over y squared is really y to the negative 2 dy. So that when we integrate, add 1 gives us y to the negative 1 times that new exponent of negative 1. So we have negative y to the negative 1 equals x squared plus c. Don't forget the plus c, you'll lose points for that. We could rewrite this as negative 1 over y equals x squared plus c. And now we use our initial condition that f of 1 equals 2 to solve for c. So negative 1/2 equals 1 squared plus c. Gives us c is negative 3/2. So now here comes the algebra part. Negative 1 over y equals x squared minus 3/2. What I did was I made the right side one fraction, get a common denominator, which would be 2. So that becomes 2x squared over 2. So we get 2x squared minus 3 all over 2 equals negative 1 over y. Why'd I do that? So we could flip both sides. So negative y equals 2 over 2x squared minus 3. So divide both sides or multiply both sides by negative 1. We get y equals negative 2 over 2x squared minus 3. You only negate either the numerator or the denominator, not both. Okay? And then we want to use that to find the value of 1.1. So sub 1.1 in for x. You can use your calculators. You get 100 over 29. Not really sure what the decimal approximation is of that. Again, it's 3 point something. You can use your calculators, get the decimal approximation to 3 decimal places. differential equation, you know, this is a definite possibility for one part of either of the questions on the test.